Hello everyone, in this video we will continue our discussion about EDA, and we have talked about variations. It's mainly about one categorical variable or one continuous variable. So in this video we will address different tools to visualize the covariation of two variables with different types. And let's go ahead and get started. It is very important that we do it differently based on different types of variables. And first of all, let's look at what if we have a categorical variable and a continuous variable, what we can do. And the dataset we are going to use is still diamonds. So to do that, you need to install the package ggplot2 first if you haven't used it. So you may want to type install.packages and then type ggplot2. And if you haven't used it before, you want to install that package first. And if you have installed it, you can just run the library function and then you load the data. The first question we are trying to solve is how does the distribution of price different for different types of cut? And we can just try to use ggplot function to draw the graphs there. So we can do ggplot, type in the dataset name, and assign the aesthetic information. So x variable would be the price, and we are going to specify color equals the variable cut. Cut is actually the categorical variable and the price is the continuous variable. So we can assign it in this way, and then we can add a new function called GEOM underline frequency polygon. Frequency polygon. So this specific geometric objects. And then we can specify the bandwidth equals 500 because the price actually have a wide range. So you want to name the bandwidth to be larger so that you don't have that many bins. Let's run that. And if you zoom the picture, you can see we are actually drawing one histogram for each type of cut. And the histogram we were drawing are according to the count, like how many values you have from 0 to 500, how many values you have from 5,000 to 5,500. So we are actually checking on the count, and you can see for the fair cut, for the good cut, the distribution is actually like squished. So you cannot really see the pattern, the real pattern of the distribution, because there are too few values for those type of cuts. And what we can do here is to still specify everything, like everything we have done. And what we need to do is to add one more thing, to add y, and then we let it to be the density. So in this way, we are actually checking on the density function, the density plot of each type of cut of their price distribution. Same thing, we do the GEOM frequency polygon, and then we specify the width to be 500. So this is like we are drawing the distribution according to the standardized counts. We are no longer using the actual number of the counts to make some of the distributions squished. So let's run this. And if you zoom the picture, you can see the y-axis is now density. You can see that for the fair cut, we are seeing like we have fewer observations of lower prices, and we have about the same amount of the higher prices as the other cuts, which seems like the average price for the fair cut is actually higher than the other type of cut. Let me call this solution 1. So we are using the actual count to show the distribution. And let me call the second one as solution 2, which we are using standardized count. So the pattern will not be disturbed by the actual count values. We are actually just checking the density. And the third solution I have, you can think about as a shortcut, for which we are going to use boxplot. Boxplot is very helpful because it shows you the median value and the middle half of the value, and also it can give you some idea about the outliers. So let's draw boxplot for now. I don't need to type data equals. You just type the dataset name, x equals cut, because when you draw boxplot, the synthetic is actually the values are on the y-axis, and the type, the categorical variable, will be the x-axis. So I specify x equals cut and y equals price, and then I add the box plot here. So this is for creating the box plot of price according to cut. And let's see. So this is the box plot. The middle line, the middle dark and thick line is the median. So you can see for the fair cut, the median is actually higher than all the other types. And we can see we do have many outliers for each type of cut. And the boxes, they have many overlap. And those are the half of those data for each cut. They are distributed from here, the lower box, the lower line of the box, and the upper line of the box. So that's 50% of the data for fair cut. Same thing. And one problem when you draw a box plot, especially of the many different types for the categorical variable, then you may want to arrange the data, arrange the box plots so it goes from maybe the highest to the lowest or lowest to the highest, so that you can easily compare them. So let's try to do that by improve this solution 3. Same thing, we are going to have ggplot diamonds, and for the aesthetic information, x is still cut, but we are going to arrange the x according to the median price. As I said, you want to arrange the boxes so that you can have an easy comparison. So you can type x equals reorder. Reorder means you are going to rearrange the boxes. And then we are reordering cut according to price. And the function we are using is called median. So we are actually calculating the median of the price, and we arrange our boxes for cut types according to the median prices. So that's our x, and y is still price, and the plot we are doing is still box plot. Everything else is the same. So you can run that, and you can zoom the picture, and you can see ideal is the lowest, has the lowest median value, and fair has the highest median value. And another thing, you can actually flip the box plot if your categorical variable names are so long. Like if I don't zoom the picture, you can see the names are actually overlapping with each other. So this one is not that much overlap, but you can actually flip the box plot to make it better fit into your report. So let's try to do that and just use this as an example, and later on we are going to do another practice and we can see how we can do it. So let's do it for now, and later on we can check on another example and you can practice to do it by yourself. So same thing, I type everything the same, and I just add a different layer, and that layer is to flip the box. So it is called coordination flip. So we are actually just adding a third layer here, and we are flipping the graph. See? So in this way, the boxes are flipped, and the highest is on the top, the lowest is on the bottom. Sometimes it may work better in this way. Looking at this graph, I think there is a problem here on the left. So it actually showed the x value we assigned as the label of the axis. So we want to change it because it doesn't look very professional. Let's do that by add a further improvement here, change the xlab. I call it xlab because you can see it showed us the x equals this part to the axis here. So we just copy the 3 lines, we add a plus sign, and then we call it xlab, and then we type the name we want to use. And we can run those lines together. And this looks much better because you can see the types of cut is on the left, the price is on the bottom. Everything looks good. So that's our 3 solutions to show the distribution of a numerical variable according to a categorical variable. And now I have a quick practice here, which is on the dataset called MPG. So the practice is on how to check the highway miles per gallon, the distribution of it according to different classes of the car. And to load that data, you just type data MPG, and you can also use the names function of that data set so that you can see HWY is a variable, class is another variable. And now you can practice to try to create the plots we have created, like how to check the box plot of HWY according to different price. How would you improve the graph? And also, how would you create the density of HWY according to different class? So you can try to practice that by following what we have done on the diamonds dataset. Okay, I just finished typing the 3 solutions for the practice. So you can run these two lines, checking the count distribution of HWY according to class. And you can see the graph is like this. And you will be disturbed by the actual count values if they are significantly different. So I go ahead and check the density distribution. And now the graph is like this. So you can see they are actually showing you a lot of information. So I would suggest you to check the box plot for it because it's so clear. And you can see mid-size has the highest HWY, pickup has the lowest. And for compact and subcompact, there are some outliers having like very high HWY. And you can see this picture is so clear to show you the differences. Like SUV is so different. SUV and pickup is so different with other types. Now let's check on the covariation of two categorical variables. When we talk about two categorical variables, it is very natural to count the number of observations for each combination of. My example question for checking the covariation of two categorical variables is that I want to see how the count for different cut and different color of the diamonds different. So cut and color of diamonds. I want to check the count for those two categorical variables. And the first solution is to just count it. And to do that, we will need to use the dplyr package. So I'm going to load the package called dplyr. If you don't have it, you need to install it first. And then load that package. And then we are going to use diamonds, pipe, and we are going to count, cut, and color. And I believe this output will be a table. And it will show us how many observations we have for each type of cut and each color. And you can see this is a long table. And it is more helpful if you want to draw graphs just to see the relationship of these two variables. And let's use ggplot again. ggplot, and then diamonds, and then aesthetic information, x equals cut, y equals color. And the geometric objects here we are going to use is called GOM count. So GOM count is for actually checking the number of observations in a graph. We can run this and we can see a graph in this way. So you can see the different size of the dots are showing different number of observations. The larger the dot is, the more observations you have. So this is our solution number 2. Draw a count graph. And solution 3 I have here is to combine the count we have here with a graph. And let's do it so you can see what I'm talking about here. So you can do diamonds, then you count the cut and color, and now you add your third pipeline, but for this pipeline we are going to draw the graph. It is still ggplot. You can use dot to denote the graph, the data you are going to use. and then you can assign the aesthetic information, and you can let x equals the color of the diamonds and y equals the cut of the diamonds. And you can also type fill equals n, the number of observations you have. And now you add your second layer. This layer is called GEOM tile, and let's run this and see what we are getting. So this is like we are building tiles of cut and color, and the lighter the color is, the more observations we have. You can see the values are ranging from 1,000 to 4,000 as the color gets lighter. Last type of covariation is for two continuous variables. And for this type of covariation, we are going to use scatterplot. And the example we are going to use here, let me name it question 3. And this question is for checking how does price and carat are related. And the aesthetic information will be x is the carat, y is the price. And you can just add another line, and you can call it GEOM point. So this is the easiest way of drawing a scatter plot. The scatter plot is like this. You can see we have too many dots around here. They are kind of all black, so you don't really know how many dots are there. And to solve that concern, we can add transparency to the data. So I'm going to copy everything in here, but I'm going to assign alpha equals 1/100. So that's to change the transparency of the values. And I just run these two lines. You can see the graph is maybe looks better because you definitely know there are way more data points here comparing with the other lighter spaces. But if you have a very large data set, the transparency may not be that helpful, so you may change the data using bins. So for this one, I'm going to still set up my drawing paper. The data is from diamonds. The aesthetic information has the same x variable and the same y variable. Instead of using GEOM point, I'm using GEOM underline bin 2D. Let's try to draw this graph and see what is exactly happening. You can see definitely it is splitting the area into little rectangles, I would say. And the lighter the color is, the more observations we are having. So this will give you some idea about looking at the general pattern, as well as seeing like if you are having a lot more observations in certain range comparing to the other ranges. So that's about it. You just learned the covariations of one categorical and one continuous, two categorical variables, and two continuous variables. So I hope you enjoyed learning it, and I'll see you in the next video.